when we discuss the Matthew effect in the communication system, what I mean, we have discussed reward system in science, the Matthew effect in the reward system, the Matthew effect in the communication system. Now, we are going to end. Okay? I mean, there is reason to assume that the communication function of the Matthew effect is increasing, is increasing in frequency and intensity with the exponential increase in the volume of scientific publications, which makes it increasingly difficult for scientists to keep up with work in their field, in their respective fields. Okay? Perhaps no problem facing the individual scientist today is more defeating than the effort to cope with the flood of published scientific research, even within one's narrow specialty. Studies of the communication behavior of scientists that within the purview of the Matthew effect in the communication system, it has shown that confronted with the growing task of identifying significant work published in their field, scientists search for cues to what they should attend to. One such cue is the professional reputation of the authors. The problem of locating the pertinent research literature and the problem of authors wanting their work to be noticed and used are symmetrical. That is, the vastly increased bulk of publication stiffens the competition between the papers for such, stiffens the competition for competition between papers for such notice. The American Psychological Association almost 50 years back found that from 15 to 23% of the psychologist readers' behaviors in selecting articles were based on the identity of the authors. The workings of that's what Robert Merton pointed out. The workings of the Matthew effect in the communication system require us to draw out and emphasize certain implications about the character of science and its associated scientific practices. And they remind us that science is not composed of a series of private experiences of discovery by many scientists, as sometimes seems to be assumed in inquiries centered exclusively on the psychological processes involved in discovery. Okay? Then science is public, science is not private. Okay? It is true that the making of a discovery is a complex personal experience, and since the making of the discovery necessarily precedes its fate, according to Merton, the nature of the experience is the same whether the discovery, whether the discovery temporarily fails to become part of the socially shared culture of science or quickly becomes a functionally significant part of that culture. That is why from the very beginning I said Merton was a functionalist within the paradigm of sociology and social anthropology, and his functionality, his functionalist orientation has delved into the such examination of science and the kind of inequalities that science has always science is always endowed with. Okay? But for science to be advanced, it is not enough that fruitful ideas be originated or new experiments developed or new problems formulated or new methods instituted. The innovations must be effectively communicated to others. That, after all, is what we mean by a contribution to science, within quote. Okay? Something that is given to the common fund of knowledge, common base of knowledge. Okay? In the end, what we get? In the end, then science is a socially shared and socially validated body of knowledge. Okay? for the development of science only work that is effectively perceived and utilized by other scientists, then and there matters. In investigating the processes that shape the development of science, it is therefore important to consider the social mechanisms that curb or facilitate the incorporation of would-be contributions into the domain of science. Looking at the Matthew effect from this perspective, from the perspective of the communication system, okay, we have what we have discussed, okay, that the distinct possibility that contributions made by scientists of considerable standing are the most likely to enter promptly and widely, okay, into the communication networks of science, and so to accelerate its development. Okay. Then what we have discussed till now, if you look at, we have discussed Matthew effect in science, how the reward and communication systems of science are considered. Okay. The Matthew effect in science, Matthew effect in the world of science, how Merton tried to delineate the psychosocial processes which affect the allocation of rewards to scientists for their contributions, that is an allocation which in turn affects the flow of ideas and findings through the communication networks of science. Okay? And such conception is based upon an analysis of the composite of experience reported in Harriet Jakerman's interviews with Nobel laureates in the United States, and upon data drawn from the diaries, letters, notebooks, scientific papers and biographies of other scientists. Harriet Jakerman was a collaborator of Robert Merton and his second wife, and then we have discussed within Matthew effect in science, that the reward system in science, the Matthew effect in the reward system, and the Matthew effect in the communication system. In the lectures to follow, what we are going to discuss, that the Matthew effect and the functions of redundancy, social and psychological basis of the Matthew effect, and the Matthew effect and allocation of scientific resources. Okay? In this context, we are going to discuss now the Matthew effect and the functions of redundancy. Constructed in this way, constructed the way we have discussed the Matthew effect in the reward system as well as the Matthew effect in the communication system, okay. Such Matthew effect in science links up, okay, the functions of redundancy in science. When similar discoveries are made by two or more scientists working independently, I mean it refers to multiple discoveries, okay, the probability that they will be promptly incorporated into the current body of scientific knowledge is increased. The more often a discovery has been made independently, the better are its prospects of being identified and used. If one published version of the discovery is obscured by noise in the communication system of science, then another version may become visible. Okay? And this leaves us with an unresolved question, that is, what is that unresolved question which Merton poses, that how can one estimate what amount of redundancy is independent efforts to solve a scientific problem will give maximum probability of solution without entailing so much replication of effort that the last increments will not appreciably increase the probability. Okay? That is a significant question on how can one estimate what amount of redundancy in independent efforts to solve a scientific problem will give maximum probability of solution without entailing so much replication of effort that the last increments will not appreciably increase the probability. I mean this question perhaps was not resolved by Merton himself. Okay. In examining the functions of the Matthew effect for communication in science, now let us refine this conception a little further. Okay? It is not only the number of times a discovery has been independently made and published that affects its visibility, but also the standing within the stratification system of science. I mean, science also is stratified, that is why it is unequally distributed, it is distributed in an uneven manner. Okay? That is why I just said that it is not only the number of times a discovery has been independently made and published that affects its visibility, but also the standing within the within the stratification system of science of the scientists who have made it. To put the matter with undue simplicity, a single discovery introduced by a scientist of established reputation may have as good a chance of achieving high visibility as a multiple discovery variously introduced by several scientists, no one of whom has yet achieved a substantial reputation. Although the general idea is at this discussion, okay, tentative, it does have the not inconsiderable virtue of lending itself to approximate test. One can examine citation indices to find whether in multiple discoveries by scientists of markedly unequal rank and file, okay, it is indeed the case that work published by the scientists of higher rank is the more promptly and more widely cited. To the extent that it is, the findings will shed some light on the unplanned consequences of such stratification system for the development of science. Interviews that Zuckerman and Merton conducted with Nobel laureates, with scientists about their reading practices can also supply data bearing on such hypothesis. Okay? This on such tentative solution to a problem or hunch. Okay? So much for the link between the Matthew effect and the functions of multiple discoveries in increasing both the probability and the speed of diffusion of significant new contributions to science. The Matthew effect also links up with the finding reported elsewhere that great talents in science are typically involved in many multiple discoveries. The statement holds for Galileo and Newton, for Faraday and Clerk Maxwell, for Hooke and others, and also for most Nobel laureates, okay, according to Merton. Okay. It holds in short for all those whose place in the pantheon of science is largely assured, however much they may differ in the scale of their total accomplishment. The greatness of these scientists rests in their having individually contributed a body of ideas, methods and results, which in the case of multiple discoveries has also been contributed by a sizable aggregate of less talented individuals, okay, scientists. For example, we have found that for example, you will find that more scientists, they get lesser amount of rewards and recognitions, and a very few scientists, well known scientists, those who have already got name and fame, they are endowed with more and more rewards and recognitions. Such inequality persists. By examining such studies, now we can detect some underlying psychosocial mechanisms, psychological as well as social mechanisms that make for the greater visibility of contributions reported by scientists of established reputation. This greater visibility is not merely the result of a halo effect such that their personal prestige rubs off on their separate contributions. Rather, certain aspects of their socialization, their scheme of values and their social character account in part for their visibility of their work. Okay? Having discussed, we have till now we have discussed the reward system in science, the Matthew effect in the reward system, the Matthew effect in the communication system, and the Matthew effect and the functions of redundancy. Now, let us see the social and psychological basis of the Matthew effect, and then we will discuss the Matthew effect and allocation of scientific resources. Before moving on to the Matthew effect in science, how the cumulative advantage and the symbolism of intellectual property, they are exhibited in terms of Matthew effect in science. Okay? But before dwelling upon cumulative advantage and symbolism in the intellectual property, symbolism of intellectual property, we will discuss the social and psychological basis of the Matthew effect. Even when some of the contributions have been independently made by an aggregate of other scientists, the great scientist or the scientist who has already acquired that eminence serves distinctive functions. It makes a difference, and often a decisive difference for the advancement of science, whether a composite of ideas and findings is heavily concentrated in the work of one scientist or one research group, or is thinly dispersed among a great number of individual scientists as well as organizations or research institutions or universities. Such a composite tends to take on a structure sooner in the first instance than in the second. It requires a Freud, psychology of mind, a study of mind, Sigmund Freud. It required a Freud, for instance, to focus the attention of many psychologists upon a wide array of ideas, which, as has been shown in many works, had in large part also been hit upon by various other scientists. Such focalizing may turn out to be a distinctive function of eminent persons of science, eminent practitioners of science. Such one Freud. Freud was one, you may say Fermi may another, Delbruck may another. They play a charismatic role in science. The way we talked about the paradigms, Kuhnian paradigms in science, Ptolemy, Copernicus in astronomy, then Galileo also of course came in astronomy, Newton and Einstein in physics, Darwin in biology. They played a charismatic role in science. They played a leadership role in science. Such paradigms excite intellectual enthusiasm among others who ascribe exceptional qualities to them. Not only do they themselves achieve excellence, they have the capacity to evoke excellence in others. This is very important. In the compelling phrase of one Nobel laureate with whom Zuckerman conducted an interview, he said that Nobel laureate said they provide a bright ambience, such paradigms, such paradigmatic figures, such charismatic leaders, they provide a bright ambience. It is not so much that these great practitioners of science pass on their techniques, methods, information and the theory to novices working with them. More consequently, they convey to their associates the norms and values that govern scientific research. I hope by now you know the normative structure of science, institutional imperatives of science, ethos of modern science outlined by Merton. Universalism, communism, disinterestedness and organized skepticism that we have already discussed. That is why the great practitioners of science, the eminent scientists, they often convey to their associates the norms and values that govern scientific research. Often in their later years or after their death, this personal influence becomes routinized in the fashion described by Max Weber for other fields of human activity. Charisma becomes institutionalized in the form of schools of thought and research establishments. In fact, Max Weber characterized different types of authority, maybe traditional authority, maybe rational legal authority, or maybe charismatic authority. And what Merton was trying to refer to, what Merton was trying to make a reference to, that was Weberian version of charismatic authority, which Bierstedt said it may be charismatic authority or leadership. The role of such charismatic leaders, such outstanding practitioners of science in influencing younger associates is repeatedly emphasized in the interviews with Nobel laureates conducted by Harriet Jacobi. Almost to an individual, they lay great emphasis on the importance of problem finding. I mean, that is what we have learnt, that identification of a problem, research question in science is very important. Not only problem solving. I mean, you have to first of all identify a problem and then you have to solve that. They uniformly express the strong conviction that what matters most in their work is a developing sense of taste, of judgment, in seizing upon problems that are of functional or fundamental importance. And typically, they report that they acquired this sense of taste, this sense of judgment, for the significant problem during their years of training in evocative environments. Reflecting on his on their years, reflecting on if a novice, if a junior scientist, who has not yet acquired such name, fame, reward, recognition, and so on. I mean, reflecting, if some junior scientist reflects on such practices, in the laboratory of a chemist of the first rank, one laureate, as Zuckerman puts it, reports that she or he led me to look for important things whenever possible, rather than to work on endless detail or to work just to improve accuracy rather than making a basic new contribution. Another Nobel laureate described her or his socialization in a European laboratory, and let me quote here, as my first real contact with first-rate creative minds at the high point of their power. I acquired a certain expansion of taste. It was a matter of taste and attitude, and to a certain extent real self-confidence. I learnt that it was just as difficult to do an unimportant experiment, often more difficult than an important one. I mean, what we are getting from this quotation, I mean from this interview conducted by Harriet Jacobi. There is one rough measure of the extent to which the laureates were trained and influenced in particularly creative research environments. The number of laureates each worked under in earlier years. Now, apparently, it is not only the experience of the laureates and presumably other outstanding practitioners of science in these environments that accounts for their tendency to focus on significant problems and so to affect the communication function of the Matthew effect. Certain aspects of their character also play a part in this endeavor. With a few exceptions, these are practitioners of exceptional ego strength. Their self-assurance finds varied expression within the context of science as a social institution. That is why from the very beginning we have said science is a social institution, science is a social creation. Okay. And that social institution, as we know, includes a norm calling for autonomous and critical judgment about one's own work and the work of others. Okay. With their own tendencies reinforced by such norms, the laureates exhibit a distinct self-confidence, which at the extreme can be loosely described as attractive arrogance. Okay. They exhibit a great capacity to tolerate frustration in their work, absorbing repeated failures without manifest psychological damage. I mean, let me quote again one laureate's view. Okay. Research is a rough game. You may work for months or even a few years and seemingly you are getting nowhere. It gets pretty dark at times, then all of a sudden you get a break. It is good to have somebody around you to give a bit of encouragement when it is required. Though attentive to the cues provided by the work of others in their field, the Nobelists are self-directed practitioners of science, moving confidently into new fields of inquiry once they are persuaded that a previous one has been substantially mined. In these activities, they display a high degree of venturesome fortitude. They are prepared to tackle important though difficult problems rather than settle for easy and secure ones. Thus, a laureate, as Zuckerman puts it, I mean, recalls having been given early in his career a problem about which there was no risk. All I had to do was to analyze the chemical composition of certain materials. You could not fail because the method was well established, but I knew I was going to work on something else instead, and the whole thing would have to be created because nothing was known about it. She or he then went on to make one of her or his prime contributions in the more risky field of investigation. I mean, one cannot keep herself or himself with the existing methods, with the existing problems. One must go beyond the existing methods, one must go beyond the existing areas of research questions as such. Okay? This marked ego strength links up with these scientists' selection of important problems in at least two ways. Being convinced that they will recognize an important problem when they encounter it, they are willing to bide their time and not settle too soon for a prolonged commitment to a comparatively unimportant one. Their capacity for delayed gratification coupled with capacity for delayed gratification coupled with self-assurance leads to a conviction that an important problem will come along in due course, and that when it does, their acquired sense of taste will enable them to recognize it and handle it. This such attitude, that ego strength, okay, has been reinforced by their early experience in creative environments. Their association with eminent scientists has demonstrated to their talented novices, as didactic teaching never could, that she or he can set her or his sights high and still cope with the problem that she or he chooses to study. Emulation is reinforced by observing successful though often delayed outcomes. Indeed, the idiom of the laureates reflects this orientation. They like to speak of the big problems and the fundamental ones, the important problems and the beautiful ones. These they distinguish from the pedestrian work in which they engage while waiting for the next big problem to come their way. As a result of all that, okay, as a result of all this, their papers are apt to have the kind of scientific significance that makes an impact, and other scientists tend to single out their papers for special attention. The character structure of these leading scientists may contribute to the communication aspect of the Matthew effect in still another way, which has to do with their mode of presenting their scientific work. Okay? Confident in their powers of discriminating judgment, a confidence that has been confirmed by the responses of others to their previous work. They tend in their exposition to emphasize and develop the central ideas and findings and to play down peripheral ones. This serves to highlight the significance of their contributions, raising them out of the stream of publications by scientists having less socially validated self-esteem, who more often employ routine exposition. Finally, such character structure and an acquired set of high standards often lead these outstanding scientists to discriminate between work that is worth publishing and that which in their candid judgment is best left unpublished, though it could easily find its way into print. The laureates and other scientists of stature often report scrapping research papers that simply did not measure up to their own demanding standards or to those of their colleagues. Okay? I mean, if you look at this, I mean, outstanding scientists of eminence, okay, tend to develop an immunity to insanable, the itch to publish. Okay, since such outstanding scientists, they prefer their published work to be significant and fruitful rather than merely extensive. Their contributions are apt to matter. This in turn reinforces the expectations of their fellow scientists that what these eminent scientists publish, at least during their most productive period, will be worth close attention. Once again, this makes for operation of the Matthew effect, as scientists focus on the output of such eminents whose outstanding positions in science have been socially validated by judgments of the average quality of their past work. And more closely the other scientists attend to this work, the more they are likely to learn from it and the more discriminating their response is apt to be. For all these reasons, cognitive material presented by an outstanding scientist may have greater stimulus value than roughly the same kind of material presented by an obscure one. Okay? A principle which provides a socio-psychological basis for the communication function of the Matthew effect. And this principle represents a special application of the self-fulfilling prophecy, somewhat as we see in the paradigms. I mean, paradigm may be Copernicus or Ptolemy or Newton or Einstein or Darwin. Okay? In this context, it is important that like other self-fulfilling prophecies, such social and psychological basis of the Matthew effect. Okay, this one becomes dysfunctional under certain conditions. For although eminent scientists may be more likely to make significant contributions, they are obviously not alone in making them. Okay? After all, scientists do not begin by being eminent. The history of science abounds in instances of basic papers having been written by comparatively unknown scientists, okay, only to be neglected for years. Consider the case of Waterston that Merton has cited, that whose classic paper on molecular velocity was rejected by the Royal Society as nothing but nonsense, or of Mendel, who deeply disappointed by the lack of response to his historic papers on heredity refused to publish the results of his further research, or of Fourier, whose classic paper on the propagation of heat and had to wait 13 years before being finally published by the French Academy. Okay? I mean, then what when the Matthew effect is thus transformed into an idol of authority, okay, non-recognition of scientific works, okay, it violates the norm of universality embodied in the institution of science and curbs the advancement of knowledge. But next to nothing is known about the frequency with which these practices are adopted by the editors and referees of scientific journals, okay, and by other gatekeepers or other so called gatekeepers of science according to Merton. Okay. This aspect of the workings of the institution of science remains largely a matter of anecdote and heavily motivated gossip. Okay. Now, having discussed the social and psychological basis of the Matthew effect in science, let us move our attention to the Matthew effect and how scientific resources have been allocated in this. Okay, the Matthew effect and allocation of scientific resources. Okay. One institutional version of the Matthew effect, apart from its role in the reward and communication systems of science, as we have already discussed, requires at least a short review. I mean, this is expressed in the principle of cumulative advantage that we are going to discuss in the lectures to follow on cumulative advantage and symbolism of intellectual property. Okay. Such institutional version is expressed in the principle of cumulative advantage that operates in many systems of social stratification to produce the same result. The rich get richer at a rate that makes the poor become relatively poorer. Thus, centers of demonstrated scientific excellence are allocated for larger resources for investigation than centers which have yet to make their mark. In turn, their prestige attracts a disproportionate share of the truly promising graduate students. This disparity is found to be especially marked at the extremes. 6 universities, namely Harvard, Berkeley, Columbia, Princeton, California Institute of Technology and Chicago, which produced, according to Merton, 22% of the doctorates in the physical and biological sciences, produced fully 69% of the PhDs who later became Nobel laureates. Moreover, 12 leading universities managed to identify early and to retain on their faculties these scientists of exceptional talent. They keep 70% of the future laureates in comparison with only 28% of other PhDs they have trained. And finally, the top 12 universities are much more apt to recruit from other American universities than they are other recipients of the doctorate. Half the laureates who were trained outside the top 12 and who worked in a university moved into the top 12, but only 6% of the sample of the doctoral recipients did so. Merton dwelt upon Zuckerman's findings to make such statements. And these social processes or psychological processes upon which we try to allocate our resources, okay, these social processes of social selection that depend the concentration of top scientific talent create extreme difficulties for any efforts to counteract the institutional consequences of the Matthew principle in order to produce new centers of scientific excellence. Now, till now then what we have discussed? I mean, we have discussed the reward system in science, the Matthew effect in the reward system, the Matthew effect in the communication system, and the Matthew effect and the functions of redundancy. And then we have discussed social and psychological basis of the Matthew effect, the Matthew effect and allocation of scientific resources, which is uneven, which is based on inequality. I mean, this exercise we are doing to reflect on the kind of inequalities which are very much prevalent in the world of science and also among the practitioners of science. Okay? Such account of the Matthew effect is another, I mean, is a small exercise in the psychosociological analysis of the workings of science as a social institution. The initial problem is transformed by a shift in theoretical perspective. As originally identified, the Matthew effect was construed in terms of enhancement of the position of already eminent scientists who are given who are given disproportionate credit in cases of collaboration or of independent multiple discovery. Okay? Its significance was thus confined to its implications for the reward system in science. to summarize, we are now trying to summarize the entire such 6 points, okay, 6 bullet points that we have discussed. By shifting the angle of vision, we note other possible kinds of consequences. This time for the communication system of science, by shifting the angle of vision, we note other possible kinds of consequences, and this time for the communication system of science. The Matthew effect may serve to heighten the visibility of contributions to science by scientists of acknowledged standing, and to reduce the visibility of contributions by authors who are less well known. What we have done, we have examined the psychosocial conditions and mechanisms, mechanisms underlying this effect, and find a correlation between the redundancy function that we have already discussed, the Matthew effect and the functions of redundancy, that the redundancy function of multiple discoveries and the focalizing function of eminent practitioners of science, that is a function which is reinforced by the great value that these practitioners place upon finding basic problems and by their self assurance. This self assurance, which is partly inherent, partly the result of experiences and associations in creative scientific environments, and partly a result of larger social validation of their position. It encourages them to search out risky but important problems, significant problems, and to highlight the results of their inquiry. A macro social version of the Matthew principle is apparently involved in those processes of social selection that currently lead to the concentration of scientific resources and talent. Okay? Then having discussed how Matthew effect in science, how it captures the reward and communication systems, how it captures both reward and communication systems of science, we will move on to the Matthew effect in science, okay? And within that we will discuss cumulative advantage and the symbolism of intellectual property, which Merton discussed, okay, after 20 years of his engagement with the Matthew effect in science, with inequalities in science. Okay. First one he published in Science, the journal Science, in 1968, and then he published his paper in ISIS in 1988. Okay. It is very important to look at the Matthew effect in science. Part 2, if I take the first one as part 1, the inequalities in science, the reward and communication systems of science as part 1, and Merton took cumulative advantage and the symbolism of intellectual property as part 2. Okay? And then in this, what we are going to discuss? We are going to discuss the Matthew effect broadly, the accumulation of advantage and disadvantage for scientists, okay, within the rubric, within the broader framework of science itself, the accumulation of advantage and disadvantage among the young, the junior scientists, then the accumulation of advantage and disadvantage among scientific institutions, organizations, research institutions, and so on, universities, then what are the countervailing processes, and then the symbolism of intellectual property in science. Okay. And the kind of symbolism of intellectual property in science that we are going to discuss, okay. But in detail we will discuss how science, which has hitherto been a public resource, has been transformed into an intellectual property. We will discuss this towards the last lectures, okay. Not now, it is the last modules we will discuss. Okay. In this context, we will start with overall the Matthew effect.